Welcome back. Let's take a look here at some additional cryptographic operations that are supported in vSphere 7, cloning, for instance, and instant clones. A lot of interesting new features in vSphere 7. We'll also look at core dump encryption as well. So, like I said, vSphere 7 added some new cryptographic operations. This is all in the name of cloning. So, when cloning an unencrypted VM, we can now encrypt the destination, right? By choosing the appropriate storage policy when you're doing this operation, right? When cloning a encrypted VM, you can decrypt the destination by changing the storage policy of the destination VM. And when cloning an encrypted VM, you can recrypt the destination VM by using PowerCLI, right? So the recrypt, right? Remember that whole shallow key or deep key, they're both available using PowerCLI. In fact, you can do both from PowerCLI. Now, cloning an encrypted VM with an instant clone, right? This is interesting, right? Instant clones are interesting new capabilities starting in 6.7. We now have them in vSphere 7 as well, with the basics where you are quickly making a snapshot and then having a new small child instance of the VM off of the source. Now, imagine if you have a child VM off of the source, you're not going to have two different VMs with different encryption keys because they are really just the same VM with a parent-child kind of association. So the encrypted instant clone will inherit the same keys. It has limitations. During the instant clone operation, the encrypted VM cannot be recrypted. After you create the instant clone of an encrypted VM, you cannot recrypt, shallow or deep, or decrypt the source VM or the destination VM, right? Imagine you can't just decrypt the parent VM while keeping the child VM encrypted. They're based on the same source virtual disk. And instant clones, by the way, are also something that can be only performed through PowerCLI. But if you're just doing a more traditional full clone, you can change the destination VM format by changing the policy, right? So when you clone a VM, you're going to go through the wizard to select where you're cloning to, and then when you get to the point of what storage would you like to save it in, you will then choose your storage policy. And again, if you choose a policy that's encryption, you can then have a non-encrypted VM cloned into an encrypted VM, or you can have an encrypted VM cloned and have the new VM or non-encrypted. So requirements for encrypting or cloning a VM, right? For encrypting, decrypting, and recrypting during cloning, these are your requirements. You need a KMS, right? I mean, that's the big requirement here, right? And if cloning occurs across ESXi hosts, both source and destination hosts must be running vSphere 7, since this whole changing the encryption, decryption, and cloning operations is a vSphere 7 exclusive. Now, one other thing I want to bring up here is being able to back up your VMs. Now, one thing about vSphere, we've had this ability to offload backup operations onto your backup server by leveraging a backup API. Yet another four-letter API. This one's called the VMware API for Data Protection, VADP. And what that does, it allows your backup server to have direct access to the SAN to bypass the ESX server. That makes a major problem when it comes to backing up a VM that's encrypted, because if we were to back up a VM from the backup server to the storage, you're pulling encrypted data that the backup server can't do any kind of file level backup, because we can't have access to the data without decrypting it. So we do need to involve the ESX servers here, right? So when you think about what are the opportunities that VADP offer? Well, they offer the ability for the backup server to have direct access to the storage. That's what's called SAN mode. The API also does allow for hot add mode, where a VM can hot add a VMDK that's to be backed up from another VM, and then we can back up from there. And then there's also what's called network block device copy, NBD, and this essentially allows the ESX server to gather the VM data and send it over the management network to your backup server. And that one always works. You can actually back up a VM that way, because now the data is being pulled off of the disk, the VMDK, through the VM kernel. The VM kernel is going to decrypt it so that we can then send it over to the backup server over the network. Hot add mode is also possible, provided the system proxy that's performing the hot add is a VM. So that's the thing to note here, right? If your VM is encrypted, SAN mode doesn't work because your backup server does need to get the VM decrypted by passing through the ESX server. And SAN mode basically says the backup server gets their own direct connection to the SAN. NBD works. What it does is it actually reads it for the VM kernel, reads the VMDK data through the VM kernel, and then sends it over the network, which can be encrypted using NBD SSL. So that's okay. It's over the network encrypted if you use the NBD SSL option. If you're using hot add mode, if it's a proxy machine as a VM, great, you can hot add, but the proxy machine must also be encrypted. If your hot add mode is used where the proxy machine is a physical machine, then this is not possible. You can't back up the VM in this method. Also, the vCenter server user registered as a backup appliance user must have cryptographic privileges since we are decrypting data as it's being backed up. So somebody has to have that privilege to be able to decrypt what would have probably been sensitive data. And keep in mind, your backup server has to read this data in from vSphere in non-encrypted form. So the backups themselves will not be backed up or will not be, they won't be encrypted by vSphere, right? The backup server may have its own backup mechanism, but as far as getting the data to the backup server, it does need to be decrypted. So the backup data stored on the backup server is in plain text, right? And so the restore privileges only to trusted users, right? And so you want to set a policy to re-encrypt any VMs that get restored. And then, yes, we have this concept called a encrypted core dump. Remember, the keys that come from the KMS are stored only in ESX server secured key cache and never stored on disk. But if the server crashes and dumps core, well, then the keys might be visible in the core dump. And what do we do with those core dumps? We send them over to our engineering folks, the troubleshooting folks inside of the support team. They probably aren't going to do anything with those keys. So you want to transmit the core dump over an encrypted fashion, but then the support engineers would need to be able to decrypt this. And the problem is that when a core dump is encrypted, it's encrypted with a host key, which is only available in the KMS and nowhere else. So that becomes unreadable by anybody, which is the whole point of it, right? It's keeping the data safe. Of course, if you needed to be able to give the support folks the ability to decrypt this, here's the trick, right? One thing to note about how core dumps work is that just like with VM encryption, there's actually a multi-key layer encryption model going on here. Basically, there is an internal one-time key that is generated by a host whenever there's a core dump. The core dump is placed into what's called a digital envelope, and that envelope and the core dump are encrypted using that internal key, which is then encrypted with the host key that was obtained by the KMS. So again, it's two keys that are involved in getting access to this data, which is not something that even the support engineering folks are going to be able to decrypt. So what you should do is, if you want this to be investigated, you've had the server crash, so you want to have it looked at. You want them to look at the core dump. What you want to do, as soon as that server does that core dump, right, it's probably sitting at the purple screen, have that server, when it reboots, immediately do an export of diagnostic data. When you perform the export diagnostic data operation, what will show in the wizard is a step to provide a password for the exported diagnostic information. Now, the export diagnostic data isn't just the core dump, right? It's a core dump, it's all the logs, and it's the configuration of the ESXi host. All that will be wrapped up into a encrypted file as long as you put a password here, right? So if you put a password that you would like to encrypt everything here, this is great. That's not the password of the KMS, right? The host key is something that nobody knows. So what we do here is, by putting a password here, the core dump will be re-encrypted. It'll be decrypted by the host key, which the host has, and it will then be re-encrypted with the key that you put here, which means it's a human-generated password that can be told to the people who need to actually open up this file. So this is a good way of, keeping the data safe. It's still encrypted, and so then you can upload the core dump, and you can also, inform them of how to decrypt this. So that was a look into those three things. We'll take one more break, and then we'll come back and finish this lesson. We'll see you in a few.